Welcome everybody to week 6, day 2. There's no class on Friday or Monday, so our next meeting will be here a week from today. The EU4 assignment is due, for that reason, 9 days from now. And I plan on giving you a lot of lab time. I want you to really see if you can get the node class and the list class done today. There are a couple interesting things I do want to talk about today. And so let's get to that 4-day weekend clap, yeah. For sure. So, first thing is move main.cc to main.cc. First thing I want to talk about is how pointers are, in some idioms, in some places, they like using pointers, just because they can. I don't know, makes them smart or something. So, a integer array here, which we'll initialize to, what's going on here? It's caps lock on, which will initialize to 0. You can iterate across this array using pointers. So you can have integer pointer equals array. That's allowed. And the reason why this is allowed is because an array is a pointer and a pointer is an array. There is a very small asterisk on that, not a pointer asterisk, but just there is one small difference in the rules where arrays and pointers are different, but it doesn't matter. So we're going to create a pointer pointing at the array, and that's the exact same thing as if we had done this here, because R is the same thing as the address of the first element in an array. So all an array is a pointer to the first element in an array. So the address of the first element of the array is exactly the same thing as R. Okay. So we can have a pointer to the end, int pointer end is equal to R plus 100. I should use a constant, but who cares? And then I can do like a while loop, while pointer is not equal to end, cout star pointer. And this will print all the elements. Let's cut this down to size a little bit. Let's make it like 20 so it doesn't overwhelm us too much. And this will print out all the elements in the array. It's like doing a for each loop or a range-based for loop. So g++ main.cc, run it. And we forgot one thing, which was to post increment the pointer. Like that. And there we go. So there's a lot of people that want to be smart by writing functions like this. Personally, I would rather go for int I equals 0, I is less than 20, I plus cout R I. I'd rather do it that way. You know what I mean? Like, it just seems a little bit easier to me. But it is, maybe it's a little bit longer, a little bit more typing, I guess. I don't know. Well, I guess you had to include these two. So yeah, people will copy from one loop to another by doing things like this, and I don't know. I'm just really not a fan of all this pointer stuff. Now, could a linked list consist of arrays or not? Yeah. So good question, Shook. So a deck is basically a linked list of arrays, and that's how you can push at the front and pop off the back of a deck. It's a vector that. It's a linked list of vectors. Okay. Can a linked list contain a linked list? Sure. It's linkception all the way down. I don't know why you do it. Maybe you have a linked list and you have 26 elements of the linked list. Each one is a letter in the alphabet, and inside of it is all the letters all the words that begin with A, right? And so you can have a linked list. Something like that. You can probably build some sort of absurd thing. Now, this thing right here is probably worth talking about. Let's say the address of R is 404. Okay. If you say pointer plus plus, so pointer is equal to 404, memory address 404, whatever. If you do pointer plus plus, pointer is now equal to 408, not 405, 408. that's why you need to know what the type is here. So the type of pointer is an int star. It is a integer, essentially, that holds the memory address of an integer. If I made this a long pointer, then this doesn't work because these are different types. The memory address of an int is not the same type as the memory address of a long. They do not work that way. Even though they're both just a memory address, C++'s type system is very strict. It does not allow you to screw up that way. It will check and fix and protect you from making bad mistakes like this. Can you auto a pointer? Yes, you can. Works fine. Now, if this was a long, and maybe we have a long array here, 64-bit integers, then every time you advance to the right, you move 8 bytes to the right instead of 4. That's why it's important to know what you're a pointer of, right? So you need to know, am I an int pointer? Am I a long pointer? Am I a what? And I don't know what it's complaining about here. Oh, this part down here. And the reason why you need to know what you are a pointer to is because when you move one element to the right, that's what this means. This means move the pointer one element to the right in the array. It needs to know how many bytes to the right to move. It's 4 bytes for an integer, regular integer, 32-bit integer. It's 8 bytes for a long. Okay. And yeah, so at Berkeley, I see a lot of code written this way. You'll copy the values from one array to another array using pointers and things like that. For me, just a regular for loop makes more sense. But you will see this in the wild. Okay. Any questions about that? Pointers are arrays are pointers. They need to know what kinds of things they point to. Also, so that when you dereference it, like if you were to see out star pointer, or even better if we say, char c is equal to star pointer. This is of type long. You need to know what the type is at that memory address. And so this is going to stuff a long into a character, which we'll do a narrowing, but if we do like string s, it won't work. No conversion from long to string. When you put a star in front of a pointer, it gives you the variable at that RAM address. So that's going to give us essentially array square bracket 0. This is the same thing as writing string s is equal to r square bracket 0. It's the exact same thing. So we're pointing at the first, no. We moved it. Okay. We moved the pointer 1 to the right. So this is the exact same thing as if we had written set string s equal to array square bracket 1. When you star a pointer like that, it's saying give me the variable at that location in RAM. Star pointer plus automatically increments the right number of bytes to go to the next element. Yes, and that's why all pointers, except for void pointers, which are kind of weird and you shouldn't use, all pointers know how big the thing are that they're pointing at, so that when you do a plus, it knows that many bytes to move to the right. Yeah, good question, Portnoff. Or Cabrera. Portnoff, this only works if the pointers are next to each other. This is an array. So in an array, you're guaranteed that it is contiguous memory. This does not work with a linked list. Okay. So with a linked list, they are not next to each other, and you should not do that. But for an array, that's what you do if you want to do a pointer-based loop. And this is very common in C world and some other places where people want to make themselves look intelligent and stuff like that. Now, let's talk about our second bullet point for today, and that is a Lambda function. So a Lambda function looks like this. That is valid C++, even though you might be questioning that it should be. Okay, so what the hell is a Lambda function? Like the word lambda, I don't know, just like there's in computer science, there's like this thing called lambda calculus and stuff. And lambda calculus, I don't even know what's going on here. You know, there's just things happening. And so what a Lambda function is actually pretty easy to understand once you get the wavelength. Yeah. What a Lambda function is a function that has no name. A lambda lamb has a B in it. Lambda function. A lambda function is a function with no name. Okay? Seems kind of weird, right? Because up until now, every time we've made a function, you have to give it a name, right? Like you got to go up here and be like int d10 is a function that will, I don't know, return 1 plus rand modulus 10. And then you can like see out d10. Okay. There we go. We got the number 4 or something. So all of our functions have names, right? That's kind of a core essential part of a function. A lambda function, a lambda functio. Lambda function is a function with no name, right? So what if we did this instead? Does the same thing. Okay. So this is calling a function. I don't know why you would do this. You would probably just do that or something, but it's doing the exact same thing. So it is a right. That's the same thing. So what it is, it's a function that has no name, and you might be going like, all right, why would you want a function with no name? You know, and how do you call it? Right? Why would you do that? Haha, exactly. Do you declare a lambda above or in main? Yeah, you don't declare it above main. That's why you do it, to answer your question. So what if you only need a function called once, right? Like, let's say we wanted to sort this array, or actually let's make a random array. This is a pretty common task, especially if you're doing like input testing and things like that. A lot of times you want to just come up with some random data, you know? So starting at the beginning of R, going to the end of R, we are going to call d10 on it. Okay? So generate is going for every element. That's what this part here is saying. For the entire range, for the entire array, R, it is going to call d10 and store the result of d10 into that slot in the array. Okay? And it takes a function pointer. It takes the name of a function, and basically it's going to call this function over and over again, and every time it calls the function, the number it gets back, it's going to get stuffed into the array. So the reason to make functions is not to repeat code, right? So there you go. So now we've randomly generated an array. Neat. So here's the thing though. If I need d10 called multiple times, I'm going to make a function called d10 and call it multiple times. But what if you only call a function once, right? And you're like, but why would you not, why do you need a function if you're only going to call it once? Well, generate takes a function. You have to have a function, right? That's what it takes. It takes a function. And so you could just make a function that is used only once in your code, but what I would rather do is do this. Rather than doing that, I would make a lambda here and return 1 plus rand modulus 10, like that. Did I forget something? Semicolon. Okay. And now I don't need d10 at all. Okay. I'm not polluting the global namespace. I have not used up one of my valuable names, because you can only have one function with that name, right? In that parameter list. So if I made a function called, I don't know, like rando, in all million lines of my code base, I can't have any other functions named rando that take no parameters, right? I've used up that name, and I've got to keep track of it. And if I need another one to generate another random array, well, then I got to come up with rando 2, you know, and then rando 7, and no. If you do this instead, it doesn't take up, you know, one of your name slots, you know. You don't have to, and you don't, names are the hardest part in computer science, right? So you don't even have to come up with a clever name for it. It's an anonymous function. So yeah, and so this code will do the exact same thing. So if I compile this and run it, does the exact same code as before, but it doesn't take up a name. This is just a function that gets called once, and we're done. And we need a function. We need it to be a function because generate takes a function as the third parameter. There's no way around it. Another example of that would be sort, right? So if you want to sort from the beginning of the array to the end of the array, you can do that. That works fine. If we do that, we get sorted least to greatest, right? Now, what if we wanted to give a custom sort function? Remember how I said you could pass in a custom sort function here? I don't want to have to make up a name for it because I just wanted to sort from greatest to least or something. So there is actually a function called grader that does that, but let's pretend it doesn't exist. And so I'm going to take in two integers, integer x, integer y, and I'm going to return y is less than x, which is backwards from what is normally the case. Okay. If I do that, now it sorts greatest to smallest. So the syntax of a lambda is you got these square brackets. That's how you know it's a lambda. It starts with this open close square brackets. And some students think of that as like the function name. It's just square bracket. It's actually not the case. It's something called Lambda Capture, which I can talk about later. And does it take less memory? It should compile down to the exact same code. It should. The only difference is if you compile your code with a real function, then that real function gets put into the .o file on its own merits. It'll get included into your .o file. Your .o file will probably be bigger. Yeah. Unless it gets inlined out or something. No, it would probably be in there. It'd probably be in there, yeah. So lambdas would probably take up a little less space. It's not something I would worry about too much. So if you make your own function, how do you specify that a parameter needs to be a function? So let me tell you how I got a job at Sony. It was that question. Or I almost got a job at Sony. Let's put it that way. I was applying at the place where the original PlayStation was made. The first 100,000 PlayStations were made there. Then they offshored the production. And I went in there for a job interview. Talked, got along fine. They wheeled in a whiteboard, and on it was this unholy looking thing. I don't know if you can see that. Zoom in here. Something that looked like this. And I just sit there and I stare at it for like a good 10 or 20 seconds. And they're like, what is that? That was their one technical question. What is that? Seriously. It's a pop-up annoyance. What the hell is that? And I said, oh, is that a function pointer? And they're like, you got the job. Let's show you around. And yeah, and then that's the type of a function. And then you can call it, you can make an array. That's actually an array. It's an array of functions. It's an array of functions. So it made an array of functions, add, subtract, and multiply. And then you're going to choose which one to call, and then it's going to call function 1, function 0, whatever, like that. The syntax is horrible, by the way. The syntax is horrible. And so, yeah, this is a compare. Comparison function object. So it is a function pointer that takes in two variables of the same type and returns true or false. So that's the type of that. But basically, yeah, function pointers have one of the most hideous syntaxes of anything I've ever seen. There's a better way of doing it. In what is the purpose of what? A function pointer? So here is an array of functions. So this is an array of functions named bug. And each function in this array takes in a vector of strings, which really should be by const reference, shouldn't it? Oof. Who wrote this code? Yeah, to do make everyone const reference. Yeah, thank you, past self. Who wrote this code? All right. But this is a array of functions, and each one of these functions returns a Boolean and takes in two vectors of strings by value of all things. And then you can call it by like this. So you dereference the function pointer and you call give me bug element 5, and it will grab that function and pass in two vectors of strings to it. Okay. And so this is something called a jump table. And so so you're asking like why? No, it's not to confuse CSI students. But like basically every time I want to add a new syntax check to easy, this is the code to easy peasy, right? Every time I want to add a new check or take a check out, bug 14 was taken out. Number 21, I guess. You just have to add another function. This is just the name of a function. So somewhere within the source directory here, grab bad indentation star.cc. So inside of bad indentation.cc, there is a function called bad indentation that takes two vectors by string, by value, ouch, and return a Boolean. Okay? And so it makes it very easy to add new checks. So if I want to extend easy peasy, all I do is I add a single entry into that jump table there, and then it'll add a new check that will find bugs in students' code and things like that. So it's an array of functions, and it just passes in their entire source code to each one of them, which is not efficient. By value, it's so painful to look at. So it passes in your source code, and then these functions that various people wrote go through the source code and look for bugs and report a bug or not. Okay. So a Lambda function can be passed to anything that takes a function as a parameter. And sort, for example, takes a comparison function. And like we saw, the comparison function takes two parameters, everything within the parentheses, just like a regular function, right? It takes two ints as parentheses. These should not be ints. These. There we go. Now they're okay. They should have been long longs, right? So this function here doesn't need, this Lambda function here does not need to exist anywhere else, right? And so why make a name for it? You only need names when you're going to refer to something again, right? If you're on the subway and you meet somebody and you're never going to see them again, it's very rare to like, hey, what's your name? Like you're just sitting on a subway and you just like randomly ask the name of the person next to you. Like, why do you want to know? Are you going to talk to me again? You know, if you go into a store and you ask for the name of an employee, like the employee's like, why do you need my name? You only need my name if you're going to use it again. And the only reason I can think of that you would want to use it again is to talk to my manager. You know, so there's always that like, you know, why are you asking my name? You know, so a horse with a name, with no name, yeah. Been to the desert with, yeah, okay. So, so if you don't need a name, if you're not ever going to use it again, use a Lambda. It's pretty nice, pretty straightforward. The square brackets is something called Lambda Capture. It allows you to capture variables from out here. So for example, if I had an int bias equals 10, then I can actually use variables from the outer scope in this function here. Just say bias. Like that. And then you can actually use variables from outside of the function they're not being passed to it like a parameter. It's just using the value in the outer scope. And that's actually kind of cool. And so you can see it's now generating numbers from 10 to 19 rather than 0 to 9. This captures that variable there and allows it to be used here inside of the function body of the lambda. Now, can you pass something to square brackets in a lambda? It's basically saying, hey, that variable that you have out there in that outer scope, I want to use it. And I don't use it very often, to be honest. Because functions to me should be sort of self-contained, right? They take input, they give output, and it sort of breaks the philosophy of a function to like have things passed to it that aren't passed to it as a parameter. I don't know. I mean, generate doesn't allow you to take any parameters, so maybe it's useful there. I don't know. You can't actually, like, the generate thing itself requires it to be a function that takes no parameters, and so this is a way of kind of bypassing it, I guess. I don't know. But I rarely use Lambda Capture. It's sort of a philosophical thing for me. Yeah, so the most common use of lambdas are in like standard library functions like this. Like if you want to just make a quick comparator that is going to sort for integers, you would just use the grader. There's a function called grader in C++. Grader square bracket int, and that you pass that to, doesn't have an example, but you just pass that function to sort, and it'll sort greater to smaller rather than smaller to greater. But like if you have a custom class or whatever, and you've got like your rectangle class or something, you want to sort your rectangle class, then you can make a comparator like this that takes in two rectangles, and it tells you what makes one rectangle bigger than another one. And if you're not ever going to do that again, then make it a lambda. Okay. If you are going to use it multiple times, just make it a normal function. Okay. But if it's just a one-off function, it's better to use it as a lambda, so you don't waste your global namespace. Keep your global namespace, as simple as possible is kind of a good philosophy. Because you only get one of them, right? You can add namespaces and things like that to hide symbols from each other, but in general, if you're only going to call a function once, then just make it a lambda. Y'all understand? That's the gist of it. Lambda. It's a Lambo function. There you go, Lambda function. Okay. Yeah, so this is valid C++. This is a function that takes no parameters, does nothing, has no lambda capture. That is a empty lambda that does nothing. So that's valid C++, even though it doesn't look like it should be. Right. Does it have any safety issues? No, they're pretty safe. I would say they're probably safer than like that array of functions, right? Because you're still going to be, you could possibly go out of bounds and things like that. Yeah, lambdas are perfectly safe. Really no difference. There is a function type in C++. So there's actually a type called function, and you can actually do something like this if you wanted. Is this in functional? It is in functional. So I can make a function of type named Bob, and set that equal to a lambda where it takes an int as parameter and sees out that variable. Now I've given it a name. Hooray. So I can now say Bob 10, Bob 20, Bob 30, Bob 40. There you go. Bob 10, Bob 20, Bob 30, Bob 40. I've made a function that only lives within the scope of this current scope. Don't I tell you? I don't know why I do that, but you can. Yeah. So there is a function type in modern C++, and the function type can hold. I think we probably even do auto type deduction. Yeah, I think that would work. So yeah, you can just say function Bob and set it equal to a lambda if you want. And now you can use it like it's a regular function, but just for this scope. And so you can have a function that only exists within one scope if you want. And that again allows you to avoid cluttering the global namespace. It's not really an issue that I'd worry about for this class, but for something like a comparator function like that, for sort, yeah, I do use that. I do use that for sure. And I use it for generate as well, to generate random arrays and things like that. Okay, what do y'all think of lambdas? Scale of 1 to 10. How much do you like it, and how much do you understand it and want to use it? I don't know. It's 3 questions. 7. It's just the same answer for all of them. Do you like them? Are they useful? Do you understand them? Just numbers on the screen now out of context. But why, says Bencourt. Will you ever have to use them in this class? I mean, have to is a strong word. There's never a case where you have to use a lambda, right? Because you can always just make a regular function, right? Like I could make a function up here called print int, takes an int. I could always do that, and rather than you, I could do you. See that? Same thing, right? You can set Bob. Bob holds a function, and you can set it equal to print it, and there's absolutely no reason to ever, like, you never have to use a lambda. It's just purely a stylistic thing where you're like, you know what, I don't want to have a print int function that is only used once or in one place, you know, because maybe someone somewhere else will want to print int function, and they want to print something else, like they want to do something, they want it to have colors or something, I don't know. Okay. Note all of the above. 35.2, -7. They seem useful for the standard library. Yeah, they actually pair really nicely with the standard library. That's a good way of putting it. So there's a lot of things in the standard library that take functions as parameters, and lambdas just go with that. So the transform, I'll give you an example here. So for example, if you have a string that contains hello, you can use transform to uppercaseify it. So transform takes a range, so over the entire range of S from the beginning to the ending. Then it takes the third parameter is where it's going to write to, and it's going to write back to the beginning of the string. And then as the last parameter here, you just see, like, this isn't on lambdas or anything. It's just like they just use it naturally. Like lambdas go really nicely with the standard library. And so you can see here, they're using, this actually tells you what the return type is. If you want to tell a lambda what its return type is, you do that weird looking thing there. So it's a function that does not do lambda capture, that takes a unsigned char C, it returns an unsigned char, and it's going to return the uppercase. They had to do that because 2upper actually returns an int, not a char. So this is a one-line uppercaseify function. Okay. Can you make a function that see how it's through a lolcat? Sure. Yeah. Why not? Maybe I'll do that before we sign off for today. Okay. But do you see what this is doing here? Do you understand it? Like, even if you don't want to use it, like, do you understand like what's happening here? Like, it's saying from the beginning of the string to the end of the string, we're going to be writing on top of it. We're overwriting it. What transform does is it gets past the first letter of the string, H. It calls to upper on it, and then it writes it back over the original. So it turns the lowercase h into capital H. And then transform calls it on E. And it passes E to the lambda returns capital E, and it overwrites E. I personally would use a range-based for loop to do this. It's a lot less typing. So, recursion, I don't know. Yeah, so there you go, hello. So transform allows you to modify an array in place and things like that. So, yeah, so lambdas are pretty common in standard library code. If nothing else, at least you can recognize them now. Yep. So the right arrow unsigned char is the return type of the lambda. You can't put the return type to the left because it would just be outside of the lambda at that point. So the square brackets sort of indicate the beginning of the lambda. And so it has this weird, like, functional, like if you've ever done functional programming languages, it has this weird functional syntax. But that's saying it returns, this is the return type, basically. Okay, so yeah, if nothing else, you've learned today how to at least recognize lambda and kind of understand what it's doing. You've learned at least to see how some people write loops using pointers. I don't write it ever that way, but at least you'll kind of know that a lot of people like doing loops. Berkeley, like I said, I have spies around the state where I have former students, kind of report back to me what their colleges are doing so that I can prepare you all for it. So it's actually a really big deal for me that when you go off to other colleges, when you transfer, that you do well. And so I'm like, so, how, and I got all this code from Berkeley where they have all these pointer-based loops and things like that. And I'm like, okay, I guess I'll show it to them, even if I don't want them to write it that way. At least you'll see it. So, yeah. In the in-person class, I went on this whole thing about you should all go to grad school and stuff like that. Long story short, getting a bachelor's degree in computer science is awesome. You'll learn a lot of things. Highly recommend it. Makes you very employable for the rest of your life. One of my students that I was talking about in the previous class, he's now working on aircraft carrier defense systems and things like that. And he bought a house or bought a condo in San Diego, so he's made it, Grad school, though, is nice because you learn all the same things again, but deeper. And you end up coming out of it with an actual pretty good understanding of computer science if you get a master's degree. And a lot of students are like, I can't afford a master's degree. Guess what? If you do research with a professor or if you TA a class and they all want TAs for classes, you usually, check with your institution, you usually will get what's called a tuition waiver and you don't pay tuition. And in fact, I got paid cash money to be a TA. I got paid $19,000 a year to teach and to do research. As a undergraduate, I worked as a TA, like Min Crowley. 1997, I was in Min Crowley's shoes, making $15 an hour, which is now minimum wage, but back then it's $26 an hour, doing research for a professor. Basically, they get grants, and then they use the grants to pay themselves, of course. 40% of it goes to the college, extortionate, but whatever. And then the rest of the money goes to hire a bunch of grad students and undergraduates. And so, as an undergraduate, I did research and with a professor of mine, he's at Berkeley now. And because of that, he I think he got me into grad school so that I could keep working with him. And as a grad student, I was making $19,000 per year, big money, which works out to $33,000 a year. Didn't pay tuition, $33,000 was enough for me to, share an apartment with somebody and have a car and eat and keep, I didn't have student loans, I only took out a student loan when in 1 month my engine and my transmission went out at the same time. That was the only time I took out a student loan because all of a sudden I didn't have any cash, right? Yeah, it's good. So if you go into grad school, it's, what I always say is you don't pay for grad school unless you want it. So, yeah, that was a rough month. That was a rough month. I was like, because I always keep a little bit of cash on hand, just in case of emergencies, and then it was just like bam, bam, and I was like, oh, my money's, So, is paying yourself as a professor with grant money legal? It's not only legal, it's required. If you want to get tenure as a professor, this last spring I took a class with Duke, and they brought in a professor who was like going over the tenure process at their institution. They're like, you have to bring in $1 million of grant money or you don't get tenure. Like that's what we tell the people coming in. If you're a new tenure track faculty, you got 4 or 5 years to bring in $1 million. And we'll work with you and help you write the grants and things like that, but that's the target. And that's how academia works at research institutions. We're a community college. We just believe in teaching. I teach because I enjoy teaching. At a research institution, they teach very little. Full-time at UCSD was 1 class per quarter, fall, winter, spring. So it works out to the equivalent of me teaching 2 classes per year. I teach 4 per semester. On top of, well, it's higher than that. Like I teach probably 6 or 7 times as much as teachers do full time at research institutions. So, yeah, you'll have to get student loans and things like that as an undergraduate oftentimes. But in grad school, you're sort of grad students are the people that kind of keep the university running. They do all the grading and a lot of times they do the teaching and they help with the midterms and all this kind of stuff. And so, yeah, like if you help teach a class in general, you get paid cash money and you don't pay tuition. And I enjoyed it. I actually just liked being a grad student for a while. I took all the classes I could because it was free. And yeah, eventually I got tired of being poor and was like, I'd rather make 6 digits rather than 5 digits. But never got my doctorate for that reason. I was ready to actually start making money. But yeah, it's not bad. It was not bad at all. So I highly encourage all of you to go to grad school, assuming you get your bachelor's. All right. So that's my little grad school lecture. Do it. It's good for you. Would you ever consider getting a doctorate? What about a doctorate? Great questions. So part of the reason why I didn't get a doctorate was because I was talking to this guy who's a recruiter, and he's like, I prefer hiring master's students over doctorates. Doctorates know one thing really well, and they know nothing about anything else. But master's students are good at everything. So when he places people with like Microsoft and things like that, he's like, that's what I look for. I look for somebody with a master's in computer science. Now, if there's a specific need, like you're doing facial recognition and you have a doctorate in facial recognition, yeah, sure, you're hired. But he was like, I see no benefit to just having a doctorate. Now, that was for a corporate recruiter, right? From an academia standpoint, if you have a doctorate, you can teach anywhere in the world, everywhere from K-12 to community colleges, state colleges, UCs, whatever. If you have a master's degree, it limits where you can teach. Like I couldn't teach at like Harvard because I don't have a doctorate, right? I can only teach at community colleges and state colleges. And generally speaking, freshman, sophomore level classes are kind of, what I'm limited to. But I like teaching it, so it's like not a big deal for me. So that might be a reason to get a doctorate if you're into that, if you're into teaching. Also, the academic game is for people with doctorates. So like if you wanna join the world of like doing research projects and like getting NSF grants and like hustling for grant money and things like that. Yeah, you got to get your doctorate to get into that world. It never really interested me too much. I mean, it's ironically I've gotten more interested in it over the years, but mostly I just wanted to get out there and make cool stuff. I want to make virtual reality classrooms where people can interact with historical figures, which I did, and traveling the world and all this kind of stuff for my business, which I did, you know. So yeah, definitely paying yourself the grant money is legal. That's the whole point of like that level of academia is you go after grants, you bring money in, it usually pays like your summer salary is usually how it works out. But it also funds the institution, and then if you do research, oftentimes your institution will buy out your time so you don't have to teach, and the grant money pays for that time. Like there's a whole thing I could give on that, but yeah, the whole grant thing is how academia works, right? So yeah, I was tempted to get a doctorate. I had already done most of the coursework. I only needed, I think, one class more to get a doctorate, but it would have been like another 2 years to go through the whole. You have to like take comprehensive exams, and like my paper was 120 pages, which was plenty long for a doctoral thesis. It would have just been another 2 years in school, and I was kind of done. Like I was like ready to not be poor, you know. Actually have a car that doesn't break down twice in 1 month, you know. Oh, you guys feel that, right? Like you just after a while, like you can just be like, yeah, I wanna be able to eat sushi. You know what I mean? Like it's kind of okay. I'm not exactly sure what I wanted to do with my Seaside degree. How do you find what you wanted to do? Great question. At first, in part, just take a bunch of classes and see what interests you. I didn't know that I liked high performance computing until I did it. Right? I always liked the idea of like a supercomputer. Because like when I was a kid in middle school, they took me into the San Diego Supercomputer Center, and we got to walk around in these rooms filled with all these giant computers, and they tell us if there's a fire, halon's going to be released, and you're all going to die. You know, I'm like, oh, that's cool, you know, and so I always kind of liked the idea of supercomputing. I didn't know that I'd like it until I took a high performance computing class, you know, and I got a C, and that pissed me off because the reason why I got a C was because the supercomputer died. I was on a experimental supercomputer and it just died, and I couldn't finish my project, and the TA's like, should have done it earlier. I'm like, it's a week before the thing's done. He's like, should have done it earlier. And all the people who did like these stupid little projects or whatever got an A on it. I got an F on it because the damn supercomputer died, and I got a C in the class, and that pissed me off because I had an A+ going into that class. And so I took the other parallel processing class, supercomputing class, with the guy that became my advisor. And I threw myself into it. I was like, oh, we're doing this. You know, I got like an A+++ in the class. He's like, wow, you're really passionate about supercomputing. You know, how would you like to work in my research lab? I'm like, I would love to. He didn't know that it was just like revenge, like anger, you know, like I was throwing myself into it because I was so mad that in the previous class I'd gotten a C for something I had just like 100% all the way down the line, you know. He's like, wow, you're really passionate. I'm like, I am. And villain origin story. Yeah, well, kind of. I mean, it worked out. It worked out really nicely. And so I worked for him as an undergraduate. He got me into grad school, I think. Or maybe I'm just good enough. I don't know. And then he offered me to become a doctorate student under him, and I turned him down. Maybe I should have taken it up. Maybe I shouldn't have. I don't know. He's at Berkeley now. Scott Baden. He's a great guy. He's just fantastic individual and great professor. And I like him a lot. I got lunch with him a couple years back before the pandemic. Yeah, Scott Baden, B-A-D-N. Like Scott Baden was my advisor. Yeah, and Fran Berman was the professor of the class that I got the C in. She ended up becoming the head of the San Diego Supercomputer Center, and I worked in her lab too. And she liked me a lot. It was just the TA was like, sorry, you know, I don't accept excuses. I'm like, the thing's dead. Like I don't know what to tell you. Like, I was one of 5 people in the world that had an account on this experimental supercomputer, and it died. Like, if I had just picked like a stupid project like Hello World on 100 machines or something, still frustrated about it. So I don't think he teaches at Berkeley. I think he just has a lab at Berkeley. They offered him to head up like one of their supercomputing labs there. So see if they know. Be cool. Couldn't handle the current. No, it was just one of those things where like it was this brand new computer architecture. It was really interesting. It had like this toroidal design and had compute and memory elements all integrated. It was like a really interesting machine, and it like they just were always like kind of tinkering with it and stuff. And yeah, so yeah. So my point is like just try different topics. Just see what you like. You know. I took computer graphics. I thought I wanted to do security, and then I took a security class. like hacking, you know, and stuff like that. And I realized there's a lot of math, and the social engineering part of it I liked, kind of the hacking and security vulnerability detection I liked. I didn't like all the like modular arithmetic and things like that so much. I like computer graphics. I like doing virtual reality stuff. Yeah, so just kind of take a lot of electives. Databases like are kind of boring, but they pay well. You know, just kind of sample a bunch of stuff, see what you like, and worst comes to worst, you get your bachelor's degree and just see who wants to hire you, and develop a passion for telephones because you got hired by a telephone company or something. You know what I mean? Like that friend of mine that graduated, he's working on aircraft carriers now. I don't think he had any interest in aircraft carriers until he got hired by a company, and they're like, you're going to be our aircraft carrier guy. He's like, oh, okay, all right, cool. And they got all these old guys to like info dump into him and stuff. So, small, simple backup project in case your main one dies. Yeah, yeah, yeah. If it was me now, I would just have like immediately. I don't know what I would have done. I would have, because the TA was kind of a jerk. You know, I probably should have gone to the professor. You know, and just be like, Fran, look, you know, the thing's down. Can I do another project? You know what I mean? Like, I in retrospect, you know, I probably could have just gone over his head and like, when it comes back up, can I take an incomplete and just when the thing's back up, I'll finish the runs that, you know what I mean? But I don't know. I think at the time I just had this mindset that like the TA's word is God, you know, and if he's like, no, you get an F, then that's all you can do, you know. But Fran was really awesome. I really liked her a lot, and I'm sure that if I had gone to her and just explained, like, look, they turned it off, it's unplugged right now, you know, for an entire week, she would have been like, she would have worked with me on it. You know? When you fail a computer program, get very angry, do 110% on the next project. Yeah, it's actually good advice. It's actually really good advice. I don't know about the angry part, but like the fire, like in an anime when like the characters are like, you know. You went to UCSD, yeah. I went to UC San Diego, and I liked it there. I liked it. I still like it a lot. The San Diego's got the best weather in the world, as far as I can tell. The UCSD computer science program is fantastic. There's a lot of fantastic programs at UC San Diego. There were some issues that I could have with it, like they would grade on style and things like that I didn't like. I talked about that in the previous class. Like if they didn't like your variable name, -1 letter grade. If they didn't like your indentation, like they didn't like this kind of indentation. They wanted hanging curly braces for everything. -1 letter grade. That kind of stuff I didn't like, but that was only in like the low level intro classes where they're like, we got to teach you proper style, and then after that, like nobody cared anymore. You know, so. Sounds like figure skating. Yeah. You get graded on style. Didn't like Kearney style truly evil. It's not that. It's actually probably a good lesson that if you go to work for a company, they're going to give you a style guide. They're going to be like, this is how we name our functions. This is how we name our variables. This is how we do indentation. You know, and so there's a reason for that. But the way that I teach style is I don't grade students on style because A, I don't want to look at it and grade it because it's too much effort. But B, yeah, like before, like when I first started teaching, like a lot of students turned in code like this. Everything's just left justified. And I was like, I can't read this. This is so horrible, you know? And so like, you know, so what I did was I wrote this compile shell script. I tell everybody to use it, right? And what it does is it runs easy peasy, the pre-check program I wrote. It runs Google's CPP check, compiles your code for you with -f sanitize turned on, -f sanitize, address sanitizer, undefined behavior sanitizer, the safe standard library turned on, a bunch of compiler flags that turn on warnings and this kind of stuff. It's a great way of compiling your code when you're starting off. And one other thing that I don't tell students, it formats your code for you. Do you see that? So what I had was, you know, there, you know, everything was like left indented, when I ran compile, it formatted it correctly. And so the reason for that is because as long as it keeps reformatting your code to the correct way, you're going to start copying it implicitly, right? So you're not going to write left indented code when it doesn't match the other things. And so that's how I do style. I just reformat your code for you the way that I like it, and then you just sort of inherently just kind of pick it up and copy it. And then I don't have to be like -1 letter grade, Bob's a dumb name, -1, trailing curly brace, no one-liners, I don't have to do any of that stuff. I just format it the way that I like, and then students just copy it, and it all works. That is why your code changes after running compile. Yeah, because I'm reformatting your code the way that according to my style guidelines. What is the #1 style guide? There isn't one. If you want to look at A-Style, which is a program that I use to reformat your code, there are after compiling, I like coming back and deleting the indentations. Yeah. Documentation. So in A-Style, you can choose all these different style guides: style Whitesmith, style VTK, style Mozilla, style GNU. And so, like on my computer, I have something called Gnu Style Check. And so, anytime you want to submit something to the GNU project, you have to run this shell script on your program, and it checks your style, and it makes sure that it matches the GNU style guide. And so, this is how you have to write code if you're submitting to GNU. The curly braces have to be like this. You have this weird old thing here. I don't even know what's happening with that. That's just bizarre, But yeah, these things are like weirdly indented. Like, I don't know. I'm not a big fan of the GNU style, but you can use A-Style to reformat your code to match the GNU style. And if you submit code to them that isn't GNU formatted, it automatically kicks it back out, saying, nope, you got to format it the right way. So, right. So, yeah, all these different projects all have their own style guides. This is Bjarne's. So he uses a attached brace in here, but he uses a trailing brace here. Kernighan and Ritchie, these are the people that made C. And so you can see that, yeah, they have the else following it like that. Bjarne does it like that. Java does it this way. So there's not like one right answer. Mozilla, Pico. Oh, that is ew. Yeah, just don't use Pico. Look at that. Oh. Yeah. Okay. Google's. Okay, actually, I like Google's. This is actually pretty close to how I do it. Okay. Yeah, but man, look at that. That is. No thanks. Okay. So you got 10 minutes left now at this point. Work on your EU4, and I will hang out. And it is actually unsettling. Yeah. I will hang out and answer your questions. Okay. So I'm going to stop the recording here. We learned a little bit of pointer loops today, a little bit about lambdas, and then about life, the universe, and everything. So thank you, everyone. Please enjoy your long weekend. Be safe, be healthy, and I will see you all in a week. All right. Peace out.